move to our next chapter, which is chapter 11, midpoint theorem. So let's see what is the midpoint theorem. Let us understand that first. Midpoint theorem states that if in a triangle the line segment that joins the midpoint of two sides of a triangle, so that means if you take the midpoint of AB, let's say this is D, and you take the midpoint of AC, which is E. So line segment that joins the midpoint of the two sides of a triangle is parallel to the third side and equal to half of it. So it says that the line segment joining the midpoint of two sides of a triangle is parallel to the third side and is equal to half of it. This implies here that since AD is equal to DB and AE is equal to CE, so this would tell me that DE must be parallel to BC and DE should be half of BC. This is the midpoint theorem. In any triangle, if you draw a line segment which is joining the midpoints of any two sides of a triangle, then it will always be parallel to the third side and it will be in length, it will be equal to the half of the third side. Is this theorem clear to everyone?
Yes, sir.
So now let us see the proving of this midpoint theorem. So what we know is that AD is equal to BD and AE is equal to CE. So it is given that AB AD is equal to BD and AE is equal to CE. Now we are doing a construction. From C, I'm drawing a line which is parallel to AD. So through C, I'm constructing a line which is parallel to AC. And I produce DE to meet this at a point F. This is what I have done, children. So that means that AD or rather AB is parallel to CF. This is by construction. And I have produced DE to meet this line at F. Is this clear to everyone?
Yes, sir.
So my construction says through C, draw a line CF parallel to AD to intersect DE produced at F. This is what we have done. Now in triangle ADE and triangle CFE, we can say that these two angles will be equal because they are vertically opposite angles. I'm trying to prove these two as congruent. So we can say that angle AED will be equal to angle CEF. They are vertically opposite angles. Then this angle here A will be equal to this angle here C, because it is forming a Z. These two are parallel lines, so they are alternate interior angles. So I can also say that angle DAE will be equal to angle ECF, and they are alternate interior angles. Also, AE is equal to EC. This is given to us already in the question. So this implies that triangle ADE is congruent to triangle CFE, and this is congruent by angle included side angle axiom. There are two angles and unke beech ka side. This further tells me that AD key value will be equal to CF. This is by CPCT. It also tells me that DE will also be equal to EF, again by CPCT. I hope this is clear, children.
Yes, sir.
Now, if you see the figure BCFD, in figure BCFD, we know that BD is parallel to CF. This is by construction, because we have already constructed that these two lines are parallel. And BD is now equal to CF. This is proved above. Because BD is equal to AD and AD is equal to CF. So this implies that BD is equal to CF. So we have already proved it. This further implies that figure BCFD is a parallelogram, because opposite sides are parallel and equal. One pair of the opposite side is parallel and equal, so this becomes a parallelogram. Now if it is a parallelogram, so this further implies that DF is parallel to BC. So we can also say that DE is parallel to BC. So we got that these two are also parallel to each other. Is this clear?
Yes, sir.
And I can say that DF will be equal to BC because the opposite sides are equal. DF can be written as DE plus EF. This is equal to BC. DE is equal to EF. So we can say 2 times of DE will be equal to BC. So the value of DE will be half of BC. Hence proved. So we have proved both the things. First, that DE is parallel to BC and that DE is half of BC. Is this clear to everyone?
Yes, sir. Yes, sir.
So this is the midpoint theorem. So whenever you are applying this theorem in the questions, you must know what you have to do. Okay, you can only apply this theorem when there is a line segment which is joining the midpoints of two sides. So if this is happening, then you can say that the line segment will be parallel to the third side and it will be equal. It will be equal to the half of the third side, to the length of the third side. Now let us see the converse of midpoint theorem. So abhi we did the midpoint theorem wherein we saw that a line segment joining the midpoints of two sides is parallel to the third side and is equal to half of it. If there is a line segment which is parallel to one side of a triangle and it is half of it, then it should, or rather we can say that a line that is parallel to one side and it bisects one side, parallel to the other side, then it bisects the third side also. To make it in simple terms, the converse of midpoint theorem says converse means उल्टा. तो अगर आपके पास एक ट्राइंगल है, let's say this is A, B and C. If you draw a line from midpoint of one side of a triangle such that it is parallel to the other side, it is parallel to this side, then it will bisect the third side. This is what we have to prove. So it is given to us in this part. It says that AD is equal to BD and DE is parallel to BC. This is given. We have to prove that it is bisecting the other side also. We have to prove that AE is equal to CE. Is this clear, children?
Yes, sir, it is clear.
Okay, so it says that a line drawn from the midpoint of one side of a triangle parallel to another side bisects the third side. Now here also we are doing the same construction. So I will be drawing from C, I'll be drawing a line that will be parallel to AB. Let's say this is G, and I will produce DE to meet this parallel line at point F. So I've done the same construction. So again, as per the construction that I have done, through C, draw a line CG parallel to AB such that DE produced intersects CG at point F. Now, in this figure, in figure BCFD, we know that DE is parallel to BC. This is given to us. So this further implies that DF will also be parallel to BC because it is the same line which was produced. Also, we can say that BD is parallel to CF because this is by construction. So if both the pair of opposite sides are parallel, then the quadrilateral is a parallelogram. So we can say that this implies that figure BCFD is a parallelogram. It is a parallelogram because both pair of opposite sides are parallel to each other. So this is a parallelogram. Now, if this is a parallelogram, I can also say that BD is equal to CF because opposite sides of a parallelogram are equal. So if BD जो है वो CF के बराबर हो गया. Now we know that AD is equal to BD and BD is equal to CF. So this further implies that AD will be equal to CF. Now again in these two triangles, in triangle ADE and triangle ECF, We can again prove them to be congruent by taking these two angles as vertically opposite angles and these two angles as alternate interior angles because the lines are parallel. So we can say that angle AED will be equal to angle CEF. They are vertically opposite angles. And angle DAE will be equal to angle FCE. They are alternate interior angles. Also, it is known that AD is equal to CF. This is proved above. So I can say that triangle ADE is congruent to triangle CFE, and this will be congruent by angle side axiom, wherein two angles and a side are equal. So if these two triangles are congruent, I can say that AE will be equal to CE by CPCT. And this is what was required to be proved. So hence proved. So therefore, if you draw a line which is from a midpoint of one side that is parallel to the other side, then it will always bisect the third side. This is what the converse of midpoint theorem says. I hope this much is clear, children.
Yes, sir.
Fair enough. Now, let's understand what do we mean by intercepts. Suppose you have three or more parallel lines. So when these lines, they are intersected by a transversal, let's say this is L, M, N, and this is P. So it is intersecting at these points like A, B, and C. So this AB, the length of the line segment AB, and the length of the line segment BC, these are called the intercepts. So if you cut these lines, if these lines are intersected by another transversal, let's say this is P, Q, and R. So here PQ and QR are called the intercepts. Is this clear to everyone?
Yes, sir.
So there is an intercept theorem that says that if there are three or more parallel lines, so for intercept theorem to take place, okay, remember that there must be three or more than three parallel lines. The intercept theorem is not going to it is applicable. I won't say it is not applicable, but generally it is not followed when there are just two parallel lines. So if there are three or more than three parallel lines which are intersected by a transversal in such a manner that it makes equal intercepts, it makes equal intercepts, तो ये equal है, then any other transversal will also make equal intercepts only. Okay, so you cut it with any other line in any which form you want to. So the theorem says that these will also be equal. So if in case AB is equal to BC, then PQ will also be equal to QR. Is this clear to everyone? This is
Yes,
what the
sir.
theorem says. So if this is L, M, N, let's say this line is P and this line is Q. This is A, B, C, and let's say this is D, E, and F. So the theorem says that if a transversal makes equal intercepts on three or more parallel lines, then any other line cutting them also makes equal intercepts. So here now we have to prove this particular theorem. So let's see how do we go about it. Well, we don't have time, so I'm